Imagine the world 12,000 years ago, coastlines that don't exist anymore, cities, if they existed, now under hundreds of feet of seawater, entire landscapes drowned, valleys that became oceans, mountains that became islands, people who watched the waters rise generation after generation until everything they knew was gone. And here's the thing, they remembered. They told stories about it, stories that spread across continents, jumped oceans, embedded themselves so deeply into human culture that we're still telling them today. Over 200 cultures around the world have flood myths. Not just any floods, the flood. A catastrophic deluge that nearly ended everything. The details change, the gods have different names, the boats look different, but the core story is always the same. Water rose, the world drowned. Only a few survived. Noah's Ark. That's the one most people know, but the Babylonians told the story of Utnapishtim thousands of years earlier. The ancient Greeks had Deucalion. The Hindus described Manu. The Aztecs spoke of Tata and Nena. Aboriginal Australians have flood stories. So do the indigenous peoples of North America, South America and Polynesia. Cultures that never met each other, separated by oceans and millennia, all describing the same nightmare. For a long time, people assumed these were just myths. You know, ancient explanations for natural disasters that early humans didn't understand. Tribal memories of local floods blown up into cosmic events. Humanity's way of making sense of a dangerous, unpredictable world. But what if they weren't making it up? What if something actually happened? Something so catastrophic, so widespread, that every culture that survived it passed down the memory? What if the Earth itself remembers? That's what this is about. Because modern geology has found something. Evidence written in ice cores, drilled from Antarctic glaciers, signatures in ocean sediments, fossilized shorelines hundreds of feet below current sea levels, underwater forests, drowned river valleys, ancient human settlements buried beneath the waves, and the timing is what makes it incredible. It all points to a period roughly 12,000 to 8,000 years ago, when the world was drowning for real. Sea levels didn't just rise, they exploded upward, in some cases jumping 10, 20, even 50 feet in a matter of decades. Coastlines retreated miles inland in a single human lifetime. Entire continental shelves, places where people lived, hunted, built communities, vanished underwater. We're talking about an event, or maybe a series of events, that would have been absolutely apocalyptic to anyone experiencing it. And people were experiencing it. Humans were everywhere by then, living along coasts, river valleys, anywhere near water. Which means when the water came, they saw it. They fled from it. And the ones who survived never forgot. This isn't pseudoscience or wild speculation. This is geology. This is what happens when Ice Age glaciers, thousands of feet thick, suddenly melt. The water has to go somewhere. It goes into the oceans, and when enough ice melts fast enough, the oceans rise catastrophically. Scientists call the most dramatic event meltwater pulse 1A. It happened around 14,600 years ago. Global sea levels rose between 50 to 80 feet in less than 500 years. Some estimates suggest it could have been even faster. That's not a myth. That's geological fact. So the question isn't whether a great flood happened. The question is when, where, and how bad was it? And maybe most importantly, what were people doing when the waters came? Were they just primitive hunter-gatherers scattered along doomed coastlines? Or was there something more? Something we lost when the seas swallowed the ancient world? Let's find out what the Earth remembers. Here's something that should make you pause and wonder. Almost every culture on Earth has a flood story, not just similar stories, nearly identical stories, a catastrophic deluge that destroys the world, a handful of survivors who rebuild civilization, waters that rise to cover mountains, and a very specific detail that shows up again and again. Advance warning that nobody else believes. Let's start with the one you probably know best, the biblical story of Noah. God warns one righteous man that a flood is coming. Noah builds an ark, saves his family and breeding pairs of animals, survives 40 days and nights of rain, eventually lands on a mountain. The waters recede. Humanity gets a second chance. Simple story. Sunday school material. Except here's the thing. That story is borrowed. We know this because we found the original. In 1872, a British archaeologist named George Smith was translating ancient Mesopotamian tablets when he discovered something that shocked the Victorian world. He found a flood story that predated the Bible by at least 1,000 years, the Epic of Gilgamesh. And it wasn't just similar to the Noah story. It was basically the same story, detail for detail. A man named Utnapishtim is warned by the gods that a flood will destroy humanity. He builds a massive boat to very specific dimensions. He brings aboard his family and animals. The flood comes, lasting 6 days and 7 nights. When the waters recede, he sends out birds to find dry land. First a dove, which returns, then a swallow which returns. Finally a raven which doesn't come back, meaning it found somewhere to land. Sound familiar? The parallels aren't subtle, they're exact. Even the bird-sending sequence is identical. This suggests either the biblical writers knew the Gilgamesh story and adapted it, or both stories preserve an even older tradition, a memory so ancient that multiple cultures inherited fragments of it. But it doesn't stop there. Cross an ocean, go back thousands of years before European contact, and you find the same story among people who should have had no connection to Middle Eastern mythology. The Hopi people of what's now Arizona tell of a world destroyed by flood because humanity became corrupt. The survivors escaped by climbing into hollow reeds that floated on the rising waters. They emerged to repopulate a cleansed earth. The Ojibwe tribes around the Great Lakes describe a great flood sent as punishment, with a culture hero named Nanabojo who survives by floating on a log and eventually recreates land by having animals dive down to fetch mud from beneath the waters. Travel to India and you'll find the story of Manu, warned by a fish that a great flood is coming. Manu builds a boat, the flood destroys all other life, and afterward he becomes the father of the new human race. The parallels to Noah are impossible to miss, but this story appears in Hindu texts that developed independently of Middle Eastern traditions. In China, the Great Flood is central to ancient mythology. The Emperor Gun tries to stop the waters and fails. His son Yu succeeds by dredging channels and controlling the waters, eventually founding the Xia dynasty. Chinese geological surveys have actually found evidence of a massive flood around 1920 BCE that fits the timeline of this myth remarkably well, but that's a story for later. Greek mythology has Deucalion and Pyrrha, sole survivors of a flood sent by Zeus to destroy corrupt humanity. They land on Mount Parnassus, receive divine instructions, and repopulate the world. Different gods, same story structure. Even in Australia, isolated from other continents for over 40,000 years, Aboriginal peoples have flood stories. The Bundjalung nation speaks of a time when the ocean rose and swallowed the coastal plains, forcing people to flee to higher ground. The Gunditj Mara people describe a great flood that covered the land, with only a few survivors escaping to mountaintops. And if you're watching this right now, wherever you are in the world, I'd love to know. Drop a comment telling me where you're watching from and what time it is. Are you falling asleep in California? Waking up in London? Somewhere I've never heard of? There's something beautiful about people scattered across the planet all wondering about the same ancient questions. So what explains this pattern? 3 possibilities, and honestly all of them are fascinating. First option, pure coincidence. Humans live near water, floods happen, scary floods become stories. Different cultures independently invented similar myths because floods are universally terrifying. This is the safe, rational explanation, but it doesn't really account for the specific shared details, the birds, the mountains, the handful of survivors. Second option, cultural diffusion. Maybe there was one original flood story that spread across the ancient world through trade routes, migration, and cultural contact. Stories traveling with merchants and refugees, mutating and adapting to fit new cultures, but preserving the basic structure. This works for geographically connected cultures, but it struggles to explain why isolated peoples in Australia and the Americas have such similar traditions. Third option, and this is where things get really interesting, collective memory. What if all these stories preserve genuine historical memory of real catastrophic floods? Not one single global deluge, perhaps, but multiple regional catastrophes so devastating they became burned into cultural memory, passed down through thousands of generations of oral tradition, until they achieved mythological status. Because here's the uncomfortable question that keeps researchers up at night. What if the myths are trying to tell us something true? What if our ancestors survived something so terrible that the memory of it literally couldn't die? 26,000 years ago, Earth was almost unrecognizable. If you could somehow travel back to the last glacial maximum, you'd find yourself on a planet that would seem utterly alien, terrifyingly beautiful, and completely inhospitable to modern sensibilities. This was a world locked in ice, a world where survival meant mastering environments that would kill you in hours if you made a single mistake. But it was also the world where humans proved they could adapt to anything, absolutely anything, if they were clever enough and determined enough. Let's start with the ice itself, because the sheer scale of it is almost impossible to grasp. Imagine an ice sheet covering all of Canada, all of it, stretching from the Atlantic to the Pacific. Now pile that ice 2 miles thick in some places. 2 miles of solid ice, heavy enough to literally push the Earth's crust down into the mantle beneath. That's the Laurentide ice sheet, and it was just one of several massive glaciers that had transformed the Northern Hemisphere into something resembling an alien world. Europe wasn't much better. The Fennoscandian ice sheet buried Scandinavia, Finland, and most of the British Isles under ice that reached thicknesses of over 10,000 feet in places. Picture this. The site where Stockholm stands today was beneath ice nearly 2 miles thick. London was on the edge of a frozen wasteland that stretched to the Arctic. Paris was tundra, cold enough that woolly mammoths grazed within sight of where the Eiffel Tower would eventually stand. Asia had its own ice problems. The Siberian ice sheet wasn't as massive as its North American and European cousins, but it covered vast territories with glaciers, tundra, and permafrost so deep it's still melting today, thousands of years after the Ice Age ended. Even places that weren't under ice were transformed. The Himalayas were even more heavily glaciated than they are now. Mountain glaciers extended thousands of feet lower than their modern positions. Valleys that today support villages and farms were filled with rivers of ice. But here's what really changed the world. All the water locked up in ice had to come from somewhere, and it came from the oceans. Sea levels during the last glacial maximum were approximately 400 feet lower than they are today. 400 feet. Think about what that means. The continental shelves, those relatively shallow underwater regions that surround every continent, were completely exposed. What's now seafloor was dry land, covered with forests, grasslands, rivers, and lakes. Entire landscapes that supported human populations, that had names and histories and cultures, were simply above water. The North Sea, that body of water between Britain and continental Europe, didn't exist. In its place was Doggerland, a vast lowland plain larger than modern England, crisscrossed with rivers that drained the melting edges of the ice sheets to the north. Doggerland wasn't some frozen wasteland. It was prime real estate, gentle terrain, abundant fresh water, rich in game animals and fish. Archaeological evidence suggests Doggerland supported substantial human populations for thousands of years. These people weren't just surviving, they were thriving, building communities, developing sophisticated hunting technologies, creating trade networks that connected groups across hundreds of miles. In Southeast Asia, the story was even more dramatic. The islands of Indonesia, Malaysia, Borneo, Java, they weren't islands at all. They were connected to mainland Asia by a landmass called Sundaland, a tropical plain the size of India. Imagine where today you see thousands of miles of open ocean dotted with islands, there was continuous land. You could walk from Thailand to Borneo without ever seeing the sea. Sundaland had everything. Rivers rich with fish, forests teeming with game, coastal areas where marine resources were easily accessible. It's no wonder genetic and archaeological evidence suggests this region supported dense human populations throughout the Ice Age. Between Siberia and Alaska, the Bering Land Bridge wasn't actually a bridge. It was a subcontinent called Beringia, stretching 1,000 miles from north to south. During the coldest phases of the Ice Age, Beringia was a cold but relatively ice-free grassland, supporting massive herds of mammoths, horses, bison, and other megafauna, and supporting the human hunters who followed them. These weren't desperate refugees fleeing harsher lands. They were skilled Ice Age hunters who had mastered one of the most challenging environments on Earth. All around the world, human populations were living on these exposed coastal plains, on lands that today lie beneath hundreds of feet of seawater. And here's what's crucial to understand. These weren't marginal environments that people only occupied because they had nowhere else to go. These were often the best places to live. Coastal plains have access to marine resources, fish, shellfish, seabirds, sea mammals. They have rivers bringing fresh water down from highlands. They have relatively mild climates compared to the frozen interior. They have the kind of environmental diversity that lets human populations grow and flourish. So who are these Ice Age people? What were they like? The archaeological record gives us tantalizing glimpses. These were modern humans, behaviorally and cognitively identical to us. They had sophisticated tool technologies, carefully crafted spear points and blades that would impress modern craftspeople. They had developed specialized clothing from animal skins and furs, sewn with bone needles that show workmanship that's genuinely impressive. They were creating art, carving figurines, decorating tools, making jewelry from shells, teeth, and carved bone. But more than their technology, these people had developed something more important. Cultural knowledge systems capable of keeping them alive in environments that would kill modern humans in days. They knew which plants were edible and when. They knew how to track and hunt animals across tundra and grassland. They knew how to find water, how to predict weather, how to survive blizzards and droughts and all the other challenges that Ice Age environments threw at them. And crucially, they knew how to pass this knowledge on to the next generation. They lived in bands, extended family groups of maybe 20, 30, 40 people. But these bands were connected in larger networks. Trade goods show up hundreds of miles from their sources, shell ornaments from the coast appearing at inland sites, stone tools made from raw materials that only exist in specific locations spreading across entire regions. This tells us something profound. These people weren't isolated survivors huddling in tiny groups. They were part of sophisticated social networks, trading, sharing information, probably gathering at certain times of year for larger meetings where groups would exchange goods, stories, and genes. The climate itself, while cold, was remarkably stable during the last glacial maximum. Temperatures didn't fluctuate wildly from year to year. The ice sheets weren't going anywhere. If you could survive in these environments, and humans obviously could, you could build a life, raise children, pass knowledge to grandchildren. Communities could persist in the same territories for thousands of years, accumulating local knowledge that became ever more refined and sophisticated. But that stability was about to end. The ice couldn't last forever. Subtle changes in Earth's orbit, variations in solar radiation, feedback loops in the climate system, all of these were beginning to shift. The world was about to transform. And the humans living on those exposed coastal plains, on Doggerland and Sunderland and Bringia and countless other now submerged lands, they were standing at ground zero for the greatest environmental catastrophe humans had ever experienced. They just didn't know it yet. Around 19,000 years ago, something shifted. Not suddenly, not dramatically, but shift it did. The Ice Age world that had locked up so much of Earth's water in massive continental glaciers began to change. Temperatures started to rise, maybe 0.5 degree per century, maybe less in some regions. To any individual human living through it, the change would have been invisible. One winter was much like the last. One summer barely distinguishable from the one before. But the ice knew. Deep in the massive ice sheets covering Canada, Scandinavia and Siberia, things were happening. Meltwater was beginning to trickle through cracks. Ancient ice that had been stable for tens of thousands of years was starting to shift, to groan, to weaken. The trigger for this gradual warming wasn't random. It was astronomical, literally. Earth's orbit around the Sun isn't perfectly circular, and our planet's axis isn't perfectly stable. Over thousands of years, these orbital characteristics change in predictable cycles called Milankovitch cycles, named after the Serbian scientist who figured them out. 3 main cycles interact like cosmic clockwork. First, Earth's orbit gradually shifts from more circular to more elliptical, and back again over about 100,000 years. Second, the tilt of Earth's axis wobbles between about 22 and 24 degrees over 41,000 years. Third, the direction Earth's axis points shifts in a slow circle over 26,000 years, like a spinning top that's starting to wobble. When these cycles align just right, they can push more solar radiation toward the northern hemisphere during summer. Not a lot more. We're talking about changes in solar energy of maybe 3 to 5%. But that's enough. That tiny increase in summer sunshine hitting the massive ice sheets was enough to tip the balance from accumulation to melt. Around 19,000 years ago, the cycles aligned. The Ice Age began its long, slow death. For the first few thousand years, the changes were subtle. Sea level started rising, but gradually. On average, about 1 meter per century. That sounds slow until you think about what it means for people living on the coast. Picture this. You're part of a fishing community, maybe 18,000 years ago. Your people have lived on this shore for generations beyond counting. You know every rock, every tide pool, every place where the fishing is good. The shore is your world. Your oral traditions speak of ancestors who lived here, who fished these same waters, who gathered shellfish from these same beaches. But something strange is happening. The elders tell stories about landmarks that used to exist further out, places their grandparents knew that are now underwater. You notice it too, in your own lifetime. That distinctive rock formation where you used to set your fishing traps, the one shaped like a bent finger pointing toward the sunrise, it's getting harder to reach at low tide. Every few years it seems a little deeper. Within your lifetime, maybe 60 or 70 years, the sea has risen about 0.5 meter, maybe a bit more. Not catastrophic. You've adapted. You've moved your settlements back a bit, found new fishing spots, adjusted your routines. But the movement continues. Your children will have to move again, and their children after them. Generation after generation, your descendants retreat inland, abandoning settlements, losing territories, watching their worlds slowly drown. This is how generational displacement works. No single event catastrophic enough to become legend. Just a slow, relentless pressure forcing communities to adapt or relocate. Over 1,000 years, the sea would rise 10 meters or more. Entire coastal plains would vanish. River valleys would become bays. Hills would become islands. But it happened so gradually that no one alive could remember a time when it wasn't happening. It became the normal background of existence. The sea rises. We move. That's just how the world works. Or so you might think. Except here's the fascinating part. Those flood myths we talked about earlier, they're not describing gradual change. They're describing catastrophe. Sudden, overwhelming disaster. Waters rising not over generations, but over days or weeks. Entire worlds consumed in what seems like an instant. If the sea level rise was always gradual, always predictable, why do flood stories across every culture describe sudden catastrophe? Why do they speak of waters that rose while people watched, that forced desperate evacuations, that left no time to save anything but your family and whatever you could carry? This is the mystery that haunts geologists and archaeologists. The average rate of sea level rise from 19,000 years ago to about 8,000 years ago was indeed about 1 meter per century. We can measure this in coral reefs that grew at different periods, in sediment layers from coastal areas, in the changing chemistry of ocean water preserved in ancient shells. The gradual rise is documented, unquestionable. But averages can hide violence. 100 years of stability followed by 10 meters of rise in a single decade still averages out to 1 meter per century. The question isn't whether the seas rose. We know they did. The question is how they rose. Gradually, like a bathtub filling so slowly you barely notice. Or in pulses, long periods of relative stability interrupted by terrifying surges when something big happened. The geological record suggests both. Background melting was continuous, driven by those Milankovitch cycles and the gradual warming they triggered. But superimposed on that gradual rise were moments of catastrophe, events that would have seemed apocalyptic to anyone experiencing them. Understanding these events requires us to think about how ice sheets actually collapse. This isn't like an ice cube melting smoothly in your drink. Ice sheets are dynamic systems with their own internal physics. They flow like glaciers, but on continental scales. They develop internal weak points where meltwater accumulates. They create massive lakes of meltwater trapped between the ice and the bedrock below. They become unstable in ways that can lead to sudden, catastrophic releases. And sometimes they do exactly that. Sometimes the gradual becomes sudden. Sometimes the predictable becomes catastrophic. Sometimes the world changes not over generations but over weeks. Those are the moments that make it into legend. Those are the floods that get remembered. But to understand them, we need to look at specific events. We need to find the geological smoking guns, evidence of moments when the gradual melt became something else entirely, something that would have terrified anyone alive to witness it, something that sounds, when described in ancient myths, exactly like divine punishment or cosmic catastrophe. The evidence is there, written in sediments and isotopes, in drowned landscapes and displaced populations. The question is whether we're ready to read it correctly. For decades, geologists have been reading a story written in stone, coral, and sediment, and what they found is terrifying. Around 14,600 years ago, something catastrophic happened to Earth's oceans. Sea levels didn't just rise gradually over millennia like they'd been doing since the Ice Age began its slow retreat. They surged, fast, violently, in a geological instant that would have seemed like the end of the world to anyone living through it. This event has a name, Meltwater Pulse 1A. Scientists love giving dramatic events boring names, but don't let the technical terminology fool you. This was the Great Flood, or at least it was one of them. One of the most dramatic sea level rise events in recent geological history, and it left evidence everywhere once you know where to look. The numbers are staggering. Over roughly 500 years, sea levels rose between 16 and 20 meters. That's 50 to 65 feet for anyone not thinking in metric. Now, 500 years might sound like a long time. Your great 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 grandparents to you. But in geological terms, 500 years is a heartbeat, and more importantly, that rise wasn't steady. The evidence suggests it came in pulses within that period, surges of meltwater that could raise sea levels several meters in just a few decades. Think about what that means. Imagine you're living on the coast 14,600 years ago. You've got a settlement maybe half a kilometre from the sea, good fishing, access to marine resources, but safe from storm surges. Your people have lived here for generations. Your grandparents' grandparents fished these same waters, gathered shellfish from these same beaches. The sea is as constant as the mountains, as reliable as the sunrise. Then, over the course of your lifetime, the ocean rises 4 meters. The beach you knew as a child is underwater. The fishing grounds your father showed you are gone, replaced by new coastline kilometers inland. The shell middens that marked your ancestors' camps are now submarine archaeological sites. By the time your grandchildren are old enough to fish, the sea has advanced another 3 meters. The settlement you were born in is abandoned, claimed by waves. Your entire world has been reorganized around a simple, terrifying fact. The ocean is eating the land. But how do we know this happened? How can scientists be so specific about an event that occurred nearly 15,000 years ago? The answer is written in coral. Coral reefs are incredibly useful for tracking ancient sea levels, because coral polyps need to live within a specific depth range to survive. Too shallow and they get exposed at low tide and die. Too deep and they don't get enough sunlight for the algae that keep them alive. So as sea levels rise, coral reefs grow upward, tracking the ocean surface like a geological tape measure. When scientists drill cores through ancient coral reefs in places like Barbados, Tahiti, and the Great Barrier Reef, they can measure exactly when the coral was alive using radiocarbon and uranium-thorium dating. Then they can calculate how deep that coral was below the surface when it died. Plot enough of these measurements, and you get a precise record of sea level changes going back tens of thousands of years. And what that record shows consistently across coral reefs around the world is a dramatic spike in sea level rise centered around 14,600 years ago. The coral doesn't lie. The ocean rose fast and it rose everywhere. Sediment cores tell the same story. When you drill into the seafloor in certain locations, you can see distinct layers that mark rapid changes in sedimentation. Around 14,600 years ago, many coastal areas show a dramatic shift. Sediments that had been accumulating slowly in shallow water environments suddenly give way to deeper water deposits. River deltas that had been building seaward for thousands of years suddenly show evidence of retreat and drowning. Entire coastal plains that had been above water become submarine shelves almost overnight in geological terms. Coastal cave formations provide even more evidence. Stalactites and stalagmites only form in air. When a cave floods with seawater, they stop growing. Scientists have found submerged caves around the world with formations that stopped growing right around the meltwater pulse 1 period. The water rose, filled the caves, and the geological clock stopped ticking. So where did all this water come from? That's where things get really interesting and a bit controversial. The 2 main suspects are the Antarctic ice sheet and the massive Northern Hemisphere ice sheets that covered North America and Europe during the Ice Age. Some evidence points to Antarctica. Computer models suggest that portions of the West Antarctic ice sheet may have been unstable during this period, If a large section collapsed rapidly, it could have released enough water to account for meltwater pulse 1a. The problem is, we don't have definitive evidence of exactly when such a collapse occurred. Other researchers point north. The Laurentide ice sheet covered most of Canada and parts of the northern United States. It was massive, kilometers thick in places, containing enough water to raise global sea levels by over 50 meters if it melted completely. Around the time of meltwater pulse 1a, this ice sheet was definitely retreating, and there's evidence of catastrophic meltwater floods in North America. Enormous glacial lakes formed at the edges of the melting ice, sometimes containing more water than all of today's Great Lakes combined. When the ice dams holding these lakes failed, biblical amounts of water would rush toward the ocean in floods so large they carved canyons and moved boulders the size of houses. The honest answer is, we're not entirely sure which source dominated or if both contributed. Maybe it was a combination, a surge of melting from Antarctica coinciding with catastrophic ice dam failures in North America and Europe. What we do know with certainty is that the water came, and it came fast. For anyone living on the coast during this period, and remember, coasts were where the best resources were, this would have been apocalyptic. Not in a single dramatic flood that drowned the world in 40 days and nights, but in a relentless generation-spanning advance of the sea. Beaches disappearing, islands shrinking, river valleys flooding, coastal caves filling with seawater. Entire landscapes transformed within living memory. This is exactly the kind of event that would burn itself into cultural memory. The kind of catastrophe that survivors would tell stories about, that would get passed down through generations, elaborated and mythologized, until it became the Great Flood. The Deluge. The time when the waters rose and swallowed the world. The world was warming. After nearly 100,000 years locked in the grip of the last ice age, the planet was finally thawing. Glaciers that had covered half of North America and Europe were retreating. Sea levels were rising as billions of tons of ice melted back into the oceans. Animals and plants were migrating north, reclaiming territories that had been frozen wasteland for millennia. And humans, those resourceful survivors of every previous climate disaster, were following the herds, spreading into newly habitable lands, building more complex societies as resources became more abundant. Then, 12,900 years ago, everything stopped. Not gradually, not as part of some predictable climate cycle. The warming just ended. Someone had flipped a switch. Within decades, maybe even within years, temperatures across the northern hemisphere plunged back toward ice age conditions. Glaciers that had been retreating for thousands of years suddenly started advancing again. Forests died. Grasslands turned to tundra. Species that had just begun adapting to warmer conditions were driven to extinction. This event has a name, the Younger Dryas. Scientists call it that because of a small Arctic flower, Dryas octopetala, that suddenly reappears in the geological record across Europe during this period. A flower that only grows in the coldest conditions, showing up in sediment layers where it had been absent for thousands of years. Physical evidence that the Ice Age had returned. The Younger Dryas lasted about 1,200 years. Then, just as abruptly as it had begun, it ended. Temperatures shot back up, even faster than they'd dropped. Within perhaps 50 years, the world went from near Ice Age conditions to the warm, stable climate of the Holocene, the period we're still living in today. But those 12 centuries of renewed cold left their mark on everything, on ecosystems, on animal populations, and especially on humans. For decades, the Younger Dryas was just a curious anomaly in climate records. Scientists knew it had happened but couldn't agree on why. The leading theory involved ocean currents, As the massive ice sheets over North America melted, they released enormous quantities of fresh water into the North Atlantic. This fresh water, being less dense than salt water, could have disrupted the ocean circulation patterns that carry warm tropical water north toward Europe. Shut down that heat conveyor belt and you get rapid cooling across the northern hemisphere. It was a neat theory. It explained most of the evidence, and it was completely wrong, or at least incomplete. In 2007, a team of researchers proposed something that sounded like science fiction. They suggested the Younger Dryas wasn't triggered by gradual changes in ocean circulation. It was caused by a cosmic impact, a comet or asteroid that slammed into the ice sheets covering North America, triggering immediate climate catastrophe and possibly wiping out most of the megafauna that had survived the Ice Age up to that point. The Younger Dryas impact hypothesis was controversial from the moment it was published. It still is. But the evidence keeps accumulating, and some of it is genuinely strange. Researchers have found a thin layer of sediment dating to exactly 12,900 years ago, precisely when the Younger Dryas began. This layer shows up at sites across North America, Europe, and Asia, and it contains things that shouldn't be there. Nanodiamonds, for instance. Tiny diamonds that form under extreme pressure and temperature, the kind you get during asteroid impacts or massive explosions. They're scattered through this sediment layer at concentrations thousands of times higher than normal background levels. Shocked quartz, mineral grains showing microscopic fracture patterns that only occur during violent impacts. Magnetic spherules, tiny balls of melted and resolidified rock, formed when material is vaporized by extreme heat and then condenses as it cools. Carbon spherules, essentially microscopic bits of charcoal, but present in such enormous quantities that they suggest continent-scale wildfires. Most intriguing of all, this same layer contains what's called melt glass, silica that's been heated to temperatures exceeding 2,200 degrees Celsius, hot enough to melt rock. You don't get that from normal wildfires. You don't get it from volcanic eruptions. You get it from impact events or massive aerial explosions. The hypothesis goes like this. 12,900 years ago, a comet fragment, possibly several fragments, struck or exploded over the North American ice sheet. The impact triggered immediate catastrophe. Massive chunks of ice vaporized instantly. The shockwave ignited wildfires across the continent. Millions of tons of debris were thrown into the atmosphere, blocking sunlight and triggering rapid cooling. The sudden melting from the impact flooded the Atlantic with fresh water, disrupting ocean currents and amplifying the cooling effect. Within years, maybe within months, the climate disaster was complete. Now, here's where this connects to the flood stories. Because the Younger Dryas didn't just bring cold, it brought water. Unimaginable quantities of water. During the Ice Age, as glaciers advanced south from the Arctic, they acted like enormous dams, blocking the natural drainage of northern rivers. Water couldn't flow north to the ocean, because the path was blocked by ice sometimes 2 miles thick. So, it pooled. It formed gigantic lakes trapped between the glaciers and the rising land to the south. The biggest of these was Lake Agassiz, covering parts of what's now Manitoba, Ontario, Saskatchewan, Minnesota, and North Dakota. At its maximum extent, Lake Agassiz held more water than all current lakes on Earth combined. For thousands of years, this water just sat there, held back by ice dams hundreds of feet tall. But ice dams have a problem. They melt, they crack, they fail. During the Younger Dryas, something happened to those ice dams. Whether it was the impact, the climate disruption, or just the normal progression of glacial melting accelerated by catastrophe, they began to break. Not slowly, catastrophically. When an ice dam holding back thousands of cubic miles of water fails, you don't get a flood, you get an apocalypse. The water doesn't seep or flow, it explodes outward with the force of thousands of rivers combined. It scours the landscape down to bedrock. It carries boulders the size of houses hundreds of miles. It raises sea levels globally within days or weeks. And if you're a human living anywhere near the coast during one of these releases, anywhere near a river valley, anywhere in the path of the deluge, you remember. Your children remember. Their children remember. The story gets told around fires for generations. The time when the world drowned, when the waters rose and swallowed the land, when everything your people had built was swept away. The Younger Dryas ended 11,700 years ago, right at the threshold of recorded human history, right when civilizations began to emerge, and every single one of those early civilizations had a flood story. Coincidence? Maybe. But the geology suggests something else entirely. The story of great floods doesn't just live in ice cores and sea level curves. It also hides in inland seas, quiet, dark, and deceptively calm. One of the most intriguing ideas of the last few decades begins not in the open ocean, but in a nearly landlocked basin between Europe and Asia, the Black Sea. In 1997, two marine geologists, William Ryan and Walter Pittman, proposed a theory that lit up both the scientific world and the imagination of anyone who'd ever heard a flood myth. They suggested that around 7,600 years ago, the Black Sea basin experienced a sudden, catastrophic flood. Not a gentle rise, not a slow, creeping shoreline, a wall of water. Their idea was simple, but dramatic. At the end of the last ice age, sea levels were much lower. The Black Sea, cut off from the Mediterranean, may have been a large freshwater lake, fed by rivers from the north. As the global oceans rose, the Mediterranean climbed higher and higher, until finally it overtopped the natural rock sill at the Bosporus, the narrow strait that today connects the Black Sea to the Mediterranean through the Sea of Marmara. According to Ryan and Pittman, when that threshold was crossed, it didn't trickle, it broke. They imagined Mediterranean seawater pouring through the Bosporus with unimaginable force, a colossal waterfall thundering down into a lower Black Sea basin, carving channels, eroding rock, and sending a surge of salt water racing across the former lake surface. In their reconstruction, the water level in the Black Sea rose tens of meters in just a few years. Some estimates suggested up to 100 meters. In human terms, that would mean the shoreline racing inland at a speed that you could watch over a lifetime. Farms swallowed, villages drowned, sacred sites disappearing beneath a rising unstoppable horizon. For people living along those ancient coasts, it wouldn't have felt like regional hydrological adjustment. It would have felt like the world itself was breaking. But was this real, or just a clever story? Ryan and Pittman weren't guessing in the dark. They pointed to several lines of evidence. First, submerged shorelines. Using sonar and acoustic imaging, researchers mapped a series of ancient terraces and beach-like features deep below the modern Black Sea surface. These look like the remains of former coastlines, flat platforms and steep breaks that, on a dry world, would have marked where waves once rolled in and out for centuries. The depths of these terraces suggested that the Black Sea had indeed been much lower at some point in the recent past, not millions of years ago, thousands. Then there were the shells. Cores taken from the seafloor showed layers of sediment containing freshwater mollusk shells, overlain by layers containing marine species, organisms that can only live in salty conditions. Even more intriguing, the transition between freshwater and marine shells in some cores looked abrupt. Not a slow mixing, but a sharp boundary. One ecology, then another. Radiocarbon dating of those freshwater shells is what produced that famous number, roughly 7,600 years before present, right in the middle of the Neolithic, a time when farming villages dotted river valleys from Anatolia to the Balkans. Not hunter-gatherer camps, but settled communities. People who'd built houses, fields, and lives along what they believed were stable shores. Acoustic imaging added more intrigue. High-resolution surveys of the seabed revealed what some researchers interpreted as rectilinear shapes, right angles, and mounded features that might be the eroded remains of human structures, foundations, walls, perhaps even entire villages now resting in deep, cold, oxygen-poor water. The Black Sea, unusually anoxic at depth, is a natural preservative. Wood, textiles, and even ancient shipwrecks stay intact for millennia there. If villages were drowned, their ghosts might still be waiting. Not long after Ryan and Pittman's book appeared, expeditions led by Robert Ballard, the oceanographer famous for finding the Titanic, went hunting for these drowned worlds. They discovered ancient shorelines, tree stumps still rooted in place far below modern sea level, and what looked like man-made features, flattened timbers, possible house foundations, shards of pottery, enough to suggest that yes, people had once lived on land that is now under the Black Sea. All of this together painted a vivid picture. A large freshwater lake ringed by early farming communities, a rapidly rising Mediterranean, a narrow rock gate at the Bosporus finally breached, thunderous waterfalls, a surging tide, human settlements swallowed in a generation. You can see why people started whispering, "Is this the Great Flood?" It's not hard to connect the dots. Just south of the Black Sea lies Mesopotamia, the cradle of some of the earliest complex societies and the birthplace of some of the most detailed flood stories on Earth. The Sumerian flood narrative, the Akkadian tale of Atrahasis, the Epic of Gilgamesh, later the Hebrew account of Noah, stories of gods angry with humanity, of divine warnings, of a single family or hero building a boat, preserving animals, and watching a world drown. Imagine people fleeing the rising shores of the Black Sea, farmers abandoning their ancestral villages, carrying with them seeds, tools, and memories of a terrifying deluge. Over centuries, they or their descendants drift south and east, settling along the great rivers of Mesopotamia, the Tigris and Euphrates. They tell their children and grandchildren about the flood that took their first homeland. Those grandchildren retell it with embellishments, mixing it with local river floods, seasonal disasters, moral lessons. Over time, the story grows, deepens, acquires gods and covenants, rain for 40 days, an ark, a rainbow. By the time scribes pressed wedge-shaped signs into clay tablets, the memory of a Black Sea catastrophe, if it happened, would have been transformed into theology, myth, and warning. A real shoreline becomes a cosmic boundary. A roaring waterfall becomes the anger of heaven. It's a compelling narrative, almost too compelling, and that's where the problems begin. Because as dramatic as the Black Sea deluge hypothesis is, not everyone agrees with it. Some geologists argue that the evidence can be explained without a sudden catastrophic event. Yes, the Black Sea was lower in the past. Yes, it used to be fresher. Yes, the Mediterranean eventually flooded in. But they suggest this happened more gradually, over centuries, not years. A significant change, but one you might not notice in a single lifetime. No thundering waterfall, no apocalyptic shoreline sprinting uphill, just slow, steady encroachment. Dating is another issue. Those 7,600-year numbers come with uncertainties. Radiocarbon calibration curves, reservoir effects, and local environmental quirks can all skew dates. Some studies suggest that the main connection between the Mediterranean and Black Sea might have occurred earlier than Ryan and Pittman proposed, or in multiple pulses rather than one big event. Others argue that the ancient shorelines don't line up cleanly with a single, short-lived flooding episode. Even the archaeological evidence is debated. Some of the structures on the seafloor may be natural formations, rock layers fractured in geometric ways, sediment features that mimic foundations. Our brains are excellent at seeing patterns, especially right angles, even when nature is just doing what nature does. And then there's the question of cultural pathways. Even if there was a dramatic Black Sea flood, did its survivors actually migrate into the regions where the earliest written flood myths appear? Or were Mesopotamian stories shaped more by the regular devastating river floods of the Tigris and Euphrates floodplains? Year after year, those rivers could wipe out crops, villages, and lives. You don't need a distant inland sea to imagine a vengeful flood. All you need is a bad monsoon. So where does that leave the Black Sea deluge? Somewhere in between certainty and legend. The geological evidence strongly suggests that the Black Sea did experience a major transition from a lower freshwater state to its current, higher, saltier condition. People were almost certainly living along its shores when that happened. Some of their settlements are now underwater. Whether the change was a roaring catastrophe or a slower, though still disruptive, transformation is still being argued. What's clear is this. Large regional floods did happen in the early Holocene. They reshaped coastlines, displaced communities, and left deep marks on human memory. Whether the Black Sea event sits at the root of Mesopotamian flood myths, or whether it's just one echo among many, it reminds us that behind every legend there may be a landscape, a shoreline, a drowned village, a place where someone once stood, watching the water rise, trying to decide what to save and what to leave behind. Imagine standing on a grassy hillside somewhere in what you'd think of today as the middle of the North Sea. Wind in the long grass, birds lifting from reed-choked marshes, a river broad and slow winding toward a distant coastline. To your left, low wooded ridges. To your right, shallow lakes dotted with waterfowl. And on the horizon, faint and hazy, the chalk cliffs of what will one day be called England, and the low plains that will one day be called the Netherlands and Denmark. But right now, none of that is an island. It's one continuous landscape. This was Doggerland. For tens of thousands of years, the seafloor between Britain and mainland Europe wasn't underwater. It was a vast lowland plain, braided with rivers, crisscrossed by animal paths, and almost certainly dotted with human camps. Red deer, wild horses, aurochs, mammoths in the earlier phases, later great herds of grazing animals. To our ancestors, this wasn't a land bridge. It was just home. And then the ice began to melt. As sea levels rose after the last glacial maximum, Doggerland shrank. Slowly at first. Year by year, generation by generation, the coastline crept inward. A marsh that had been reliable for fishing turned brackish. A favourite hunting ground flooded more often in spring. Maybe elders pointed to the waterline and told children, the sea used to be there. Eventually the changes stopped being subtle. Geologists can trace the drowning of Doggerland in stages. What had once been a giant plain becomes an archipelago of low islands, then shallow banks, then nothing but waves. Somewhere in that drawn-out catastrophe, people had to move. Camps that had been used for centuries were abandoned forever. Trails vanished beneath tides that never went out. We know Doggerland existed not just from maps of the seafloor, but from what gets dragged up by accident. Modern fishing trawlers, scraping nets along the bottom of the North Sea, keep pulling the past to the surface. Not just shells and peat clumps, but bones. Mammoth tusks stained brown by the sediment, antlers from giant deer, jawbones of lions that once prowled those plains, and mixed in with them artifacts, stone tools shaped by human hands that never saw the ocean you know, flint blades, scrapers, spear points with polish from long use, occasionally something even more intimate, a carved fragment of antler, a worked piece of bone, a human skull fragment rolled and abraded but still identifiable as one of us. Each object is a message from a drowned world. Archaeologists working with these finds and with seismic scans from oil and gas surveys have begun to reconstruct Doggerland in remarkable detail. They can see ancient river systems, former lake basins, even what looks like the outlines of old coastlines and estuaries. It was, as far as we can tell, prime real estate for Mesolithic hunter-gatherers. Rich wetlands, abundant game, mild compared to the harsher inland climates. And then the sea took it all back. If you were living there as the water rose, what would that feel like? Not a Hollywood wall of water, at least not usually, more like a slow betrayal. A world that was shrinking in on you. Landmarks disappearing within a single lifetime. Stories accumulating about the old places now under the waves. Multiply that experience by many coasts, many continents, many generations, and you begin to sense how a memory of the world drowning might root itself deep in human imagination. Doggerland wasn't unique. It was just one piece of a much larger pattern. Shift your mental map now to Southeast Asia at the peak of the Ice Age. What you see is not the maze of islands you know from modern maps, but a gigantic subcontinent, Sundaland. The Malay Peninsula, Sumatra, Borneo, Java, Bali, and a web of now-drowned plains all formed a single continuous landmass stretching far out into what is now the Java Sea, the South China Sea, the Gulf of Thailand. Broad river valleys flowed across this exposed shelf, joining into massive systems that drained into a coastline far to the south and east of today's shores. To hunter-gatherers, Sundaland would have been a paradise. Tropical climate, dense forests, rivers thick with fish, coastal plains rich in shellfish and mangroves. Genetic and linguistic evidence suggests this region may have hosted large, stable human populations for a very long time. As sea levels rose, Sundaland fragmented. Those great river valleys became narrow straits. Hills became islands. Once continuous populations were split apart, trapped on higher ground as the lowlands drowned. What had been a single cultural landscape splintered into archipelagos? Some researchers think echoes of this fragmentation survive in later Southeast Asian flood stories. Myths of lost coasts, sunken lands, drowned forests. We can't prove a direct link, but it's not hard to imagine people watching the sea climb, retelling the story of that loss around evening fires century after century until it hardened into legend. Move west again, to the Middle East. Today the Persian Gulf is a shallow arm of the ocean, hemmed in by modern nations. But during low sea level stands, most of that basin was dry land, fed by the ancestors of the Tigris, Euphrates, Karun, and other rivers. It may have formed a fertile interior plain, a sheltered refugium in an often harsh region. Some archaeologists have proposed that this Gulf basin could have been a kind of prehistoric garden, rich wetlands, abundant fresh water, a stable microclimate compared to the more arid lands around it. A place where early groups could settle more permanently, experiment with intensive foraging, maybe even the very earliest plant management long before formal agriculture. If people did live there in great numbers, almost all traces of their camps, their trails, their sacred places are now under 60 or more meters of seawater. As the post-glacial ocean pushed in through the Strait of Hormuz, that hypothetical Eden would have flooded piece by piece, first the outer lowlands, then the inner marshes, finally the central plain. Later peoples living on the surrounding highlands might have inherited stories from ancestors who had to flee that slow invasion of water, stories about a lush land now lost beneath the sea, a garden of abundance that the ocean swallowed. Again, we can't say for certain. But the fit between geology and mythology is suggestive. Far to the east and south, another drowned world tells a related story. During the Ice Age, lower sea levels connected Australia, Tasmania and New Guinea into a single continent, Sahul. Dense tropical forests in the north, arid interiors in the south, long river systems crossing what are now shallow seas. The people who first reached this landmass had to cross deep water channels somewhere along the way, which means they already possess some form of watercraft and navigation tens of thousands of years ago. Once there, they spread across Sahul, occupying coasts and inland corridors that have since vanished under rising seas. Ancient Aboriginal oral traditions in Australia describe shorelines where desert now lies, volcanic eruptions that geological evidence dates to tens of thousands of years ago, and sometimes, in more fragmentary form, lands and pathways no longer visible. On the northern side, Sahul's connection to New Guinea was eventually severed by rising waters, isolating populations that had once been neighbours. On the southern side, Tasmania was cut off from mainland Australia in a similar way. People woke up one morning to find that the low, marshy plain they had always crossed was now a widening channel of salt water. Again and again in Doggerland, Sunderland, the Persian Gulf, Sahul, the same pattern plays out. Vast tracts of habitable land exposed during the Ice Age, rich and inviting, then slowly, inexorably reclaimed by the sea. From the perspective of geology, this is normal. Coastlines migrate, shelves flood, continents breathe in and out with the cycles of ice and melt. From the perspective of humans living through it, it must have felt anything but normal. Imagine being told as a child about the old village out there, somewhere under the waves. Imagine your grandparents pointing toward the horizon and saying, "Our people used to live where the sea is now." Imagine learning that your sacred grove, your ancestors' burial ground, your best fishing creek had all been swallowed, not by enemy warriors, not by fire, but by the slow, patient rise of water. Those are the kinds of experiences that stick. They shape migration. They push people inland, up river valleys, into new territories where they meet and mix with other groups. They change technology as communities experiment with new boats, new fishing methods, new ways of building on higher, safer ground. They change religion and myth as water becomes not just a source of life but a force of erasure. And somewhere in that tangle of memories, Doggerland's drowned plains, Sunderland's vanished rivers, the lost wetlands of the Persian Gulf, the broken bridge of Sahul, our ancestors began to weave a larger story. A story not just about a local flood or a single river overflowing, but about the world itself once being lower, wider, safer, and then being taken away. Later cultures would turn that feeling into epic tales, stories of gods angry or sorrowful, of righteous few saved on boats or mountains, of lands punished, cleansed, renewed. But beneath the theology, beneath the poetry, there may lie a simpler, older memory. The seas rose, the land shrank. We had to move, or we would die. The earth had changed the rules again, and our species did what it always does when cornered. We adapted. We remembered. And we told each other in 100 different languages never to forget what it feels like when the ocean comes for your home. If you want to know what really happened with any so-called great flood, you can't start with myths. You have to start with rocks, with ice, with mud at the bottom of dark, silent lakes. Because the earth keeps a diary. It just doesn't write in ink. It writes in layers. Geologists spend their lives learning to read those layers. To them, a cliff isn't just a wall of stone. It's a bookshelf. Each band of rock is a chapter. Each change in colour, texture or composition is a plot twist. When they say, "We know sea level was higher here 14,000 years ago," they aren't guessing. They're translating. One of the clearest sentences in this planetary diary comes from coral. Coral reefs are picky architects. Most reef-building corals live in shallow, sunlit water, usually within a narrow depth range below the surface. Too deep and they starve. Too shallow, and waves tear them apart. So wherever you find ancient coral, locked in stone high above today's sea level, you're looking at a fossilized coastline. In many parts of the world, Especially around tropical islands, the landscape is carved into step-like platforms called coral terraces. To a casual observer, they're just pretty cliffs. To a geologist, they are ancient sea levels frozen in place. Each terrace is a former shoreline, a place where waves once broke and corals once thrived before the land slowly rose or the sea fell. You can walk up these terraces like stairs through time. The lowest step might match a sea level only slightly higher than today. The next step up might correspond to an earlier warm period, when ice sheets melted and oceans swelled. Higher still, you reach corals that grew when the last ice age was ending, and water was racing into the seas faster than at almost any time in recent history. By sampling those corals and measuring tiny radioactive elements inside them, scientists can estimate when each terrace formed, sometimes to within a few hundred years. Stitch terraces from different islands together, and a global picture emerges. Sea levels that rose and fell, sometimes slowly, sometimes in dramatic leaps. Leaps like meltwater pulse 1A. But coral is only part of the story. While reefs were building their stony skeletons in warm oceans, in the far north and south the ice was keeping its own records. Greenland and Antarctica are layered like giant frozen scrolls. Each year snow falls, compresses and becomes ice. Dust settles. Volcanic ash drifts down from distant eruptions. Tiny bubbles of air get trapped, perfect little time capsules of ancient atmospheres. Drill down into these ice sheets and you're travelling backwards through time, year by year, storm by storm. Some ice cores contain hundreds of thousands of annual layers. Summer and winter stack on top of each other like pages in a book. From these pages, scientists can read past temperatures, greenhouse gas concentrations, even traces of massive wildfires or cosmic events. Sharp changes in the chemistry of the ice tell us when the climate lurched suddenly colder or warmer. For floods, this is crucial. A sudden spike in temperature means ice sheets melting. Melting means water. Water means rising seas. But if ice cores and coral terraces tell us when and how fast the water rose, sediments tell us what it did when it got there. When a calm river flows, it lays down fine, well-sorted layers of sand, silt and clay. But when a catastrophic flood surges through a valley, it doesn't behave politely. It rips up soil, boulders, trees, anything in its path. The deposits it leaves behind are chaotic. Thick beds of mixed grain sizes rip up clasts of older sediments, sometimes giant boulders stranded far from their sources. In coastal regions, storm surges and tsunami-like waves can leave their own signatures. Sheets of sand thrown inland over marshes and soils, marine shells mixed with terrestrial material, abrupt changes in the normal layering at the bottom of bays and estuaries. Deep in the ocean, sudden underwater landslides triggered by sea level changes can create thick, distinct layers of coarser material in otherwise fine mud. When geologists slice into these layers, they're looking for patterns. Was this laid down slowly, year after year? Or did it arrive all at once in a violent event? A single thick, jumbled deposit sandwiched between orderly layers can scream catastrophic flood. Some of the most delicate records of all come from quiet lakes. In certain cold, still lakes, sediments settle in thin annual layers called varves. Light, coarse grains drop out in energetic spring meltwaters. Darker, finer particles sink in the calm of winter. 1 year, one pair of layers. Over centuries and millennia, these build up into a natural calendar. Varves are precise. You can sit with a microscope and literally count back year by year, sometimes for tens of thousands of years. Sudden, thick, disrupted layers in a varve sequence can show when a landslide crashed in, when a glacier lake burst, or when flood waters briefly overwhelmed an otherwise placid basin. Compare these timelines from many lakes, and you can see whether a disturbance was local, regional, or something bigger. To put absolute dates on all of this, scientists lean heavily on radiocarbon dating. Every living thing contains a small amount of radioactive carbon-14, formed in the upper atmosphere and cycled through plants, animals, and oceans. When something dies, it stops taking in fresh carbon, and the carbon-14 it holds begins to decay at a known rate. Measure how much carbon-14 is left in a piece of ancient wood buried in a flood layer, or in a shell from an uplifted coral terrace, and you can estimate how long it's been dead. Combine that with other methods, uranium-thorium dating in corals, argon-argon dating in volcanic ash layers, even luminescence dating of sediments, and you start building a much more solid timeline. But none of this is simple. The Earth doesn't label its layers. It doesn't tell you when something was local and when it was global. A chaotic bed of sediment might be a once-in-10,000-year flood, or just the worst storm in a century. Coral terraces can be tilted by tectonic movements, confusing their original heights. Ice layers can get folded and distorted deep in the core, scrambling the sequence. Radiocarbon dating has its own wrinkles. The amount of carbon-14 in the atmosphere has changed over time, so raw radiocarbon ages need to be calibrated using other records, like tree rings and varves. Old carbon can contaminate younger samples. Organic material can move through sediments. Every date comes with error bars, with uncertainty. This is where recent technology has changed everything. High-resolution satellite mapping can reveal drowned river valleys and ancient shorelines on continental shelves, tracing where coastlines used to be when seas were lower. Multi-beam sonar can scan the seafloor in stunning detail, showing old beach ridges, cliff lines, even former lake beds now hundreds of meters underwater. Computer models fed by ice core and coral data can simulate how ice sheets responded to climate shifts, how quickly they melted, where all that water went. Tiny chemical signatures in individual sand grains can reveal where they came from and how fast they traveled. Ancient DNA trapped in sediments can tell us what plants and animals lived in a place before and after a flood. Piece by piece, this web of evidence is knitting together a story, not of a single global deluge that drowned every mountain, but of many floods, some unimaginably large, spread across thousands of years and continents. Sudden pulses of meltwater roaring off collapsing ice sheets. Coastal plains swallowed as seas climbed higher step by step. Inland lakes overfilled and then bursting through their own walls in hours. The geological record doesn't erase the myths, it reframes them. It suggests that behind tales of world-ending waters may lie memories of very real catastrophes, filtered through generations of storytelling. And as we refine our tools, as we read the Earth's memory with greater and greater clarity, we move a little closer to answering a haunting question. When ancient people spoke of the Great Flood, what exactly were they remembering? Trying to pin down the Great Flood is a bit like trying to catch mist with your hands. The stories feel solid. They have names, heroes, places, but when you press them against the geological record, they start to dissolve, to spread out over thousands of years, over multiple disasters, over events that happened long before anyone carved cuneiform into clay or inked symbols onto papyrus. This is where myth meets science, and where things get wonderfully complicated. Geologists can date water, not in the way you'd date a fossil bone, but in the traces it leaves behind. Layers of silt suddenly dumped where there should be soil. Beaches stranded far above modern sea level. Drowned river valleys, buried forests, coral reefs that abruptly stop growing at a certain height and then restart meters above. These are the fingerprints of ancient floods. Myths have their own fingerprints, repeating patterns. The good, righteous, or clever survivor. The warning ignored. The water that rises higher than anyone thought possible. The world, or at least the world of the storytellers, wiped clean and started again. The temptation is obvious. You look at a myth from Mesopotamia about gods drowning the world, and then you look at a coastline where sea level rose dozens of meters in a geological blink, and you want to say, there, that's it, that's the flood. But the timeline refuses to cooperate. Most written flood stories are surprisingly recent in geological terms. The Sumerian and Babylonian versions, like the tale of Utnapishtim in the Epic of Gilgamesh, were written down in the last 4,000 to 5,000 years. The biblical story of Noah takes shape in roughly the same broad window. Greek myths about Deucalion and Pyrrha, Hindu stories of Manu and the Great Deluge, Chinese legends of Yu the Great taming the floods. These are all products of the late Neolithic and early Bronze Age worlds. By the time those stories were told, sea level had already done its most dramatic rising. The gigantic meltwater pulses that drowned continental shelves and turned lowlands into seas mostly happened thousands of years earlier, between about 14,000 and 8,000 years ago. If you try to match the written myths directly to the biggest known global flood signals, the dates just don't line up neatly. So maybe the question is wrong. Maybe there wasn't one great flood. Maybe there were many. Imagine being born in a village on a low coastal plain. The sea has been creeping closer your whole life. Not fast enough to notice between one day and the next, but just fast enough that the old people keep muttering that the shoreline used to be over there. Then one year the storms are worse, the tides are higher, a storm surge combines with a spring tide, breaks through dunes that have held for generations, and suddenly your village is gone. Everything your world depended on is underwater. For you, that's the flood that destroyed the world. Now imagine another group living by a great river fed by glaciers far away. One summer, the snows melt too quickly, an ice dam fails, the river swells into a monstrous wall of water, rolling boulders the size of houses, stripping away soil, forests, entire settlements. To them, that's the flood. Different place, different cause, same feeling of total annihilation. Multiply this over thousands of years, during a time when climate was unstable, when ice sheets were retreating, when coastlines were still adjusting to a post-Ice Age world. You don't get one flood. You get hundreds of local apocalypses. The 8.2 kilo-year event is one of the most intriguing candidates for a shared memory. About 8,200 years ago, something dramatic happened to the climate. A massive glacial lake in North America, dammed by the last remnants of the great ice sheets, suddenly drained into the North Atlantic. The surge of fresh, cold water disrupted ocean circulation. For a brief period, maybe a century or two, global temperatures dropped. Rain patterns shifted. Some regions became much drier, others wetter. Floods and droughts arriving in places that had grown used to relative stability. If you were living in the Near East, or around the Mediterranean, or along major rivers in Europe or Asia at that time, it might have felt as if the world itself had become unstable. Crops failed. River levels changed unpredictably. Floods came at the wrong seasons, higher than before. The sky and water were no longer behaving according to the rules your ancestors relied on. This wasn't a single towering wave washing over continents. It was a cascade of regional disasters, all triggered by the same climatic jolt. It's possible that some of the older layers of flood mythology, the sense of a world out of balance, of a catastrophic break between before and after, have their roots in this event. But now we run into another problem: memory. Oral tradition is powerful, but it's not a tape recorder. Anthropologists studying living cultures have found that stories can persist in recognizable form for hundreds, sometimes even a couple of thousand years. Certain core elements remain stable, especially when they're tied to ritual, to sacred places, to seasonal cycles. Ancestral lands swallowed by rising seas, a legendary flood that forced a migration. These can echo for a long time, yet over very long spans, Many thousands of years, details drift. Different disasters get folded together. A flood, a famine, a war, a volcanic eruption all become chapters in one grand ancestral catastrophe. Characters merge, motives change. A freak storm becomes divine punishment or a test or a moral lesson. What begins as the river broke its banks when the mountain snow melted too fast might, generations later, be retold as the gods grew angry at human noise and sent waters to silence us. So even if a myth does preserve a real flood, it probably doesn't preserve it like a documentary. It preserves the emotional truth, the terror of losing everything, the awe at nature's power, the fragile hope of a few survivors starting again. The geological specifics blur. This is why different cultures' flood stories feel so similar and yet refuse to map neatly onto a single event. They might all descend from a few exceptionally bad centuries, like the 8.2 kiloyear event. They might remember regional disasters tied to the final drowning of lowlands such as the Black Sea Basin, the Persian Gulf, Doggerland, Sunderland, and other lost coastal worlds. Or they might be independent responses to smaller, more local floods that just happen to follow the same human script, and over time, those multiple memories can fuse. Imagine one group whose ancestors survived a coastal inundation 9,000 years ago. 1,000 years later, their descendants experience a catastrophic river flood. Which story do they tell their children? Probably both. But the edges blur. The two events become one grand deluge, with elements borrowed from each. A few centuries beyond that, they meet neighbouring peoples who have their own flood legends, shaped by their own disasters. Stories are shared, compared, combined. The most dramatic elements survive. The quieter details fade. By the time scribes finally scratch the stories into clay tablets or parchment, what's left is a mythic superflood. Higher, longer, more total than anything any single community ever saw. A composite disaster, built from many real ones. Science can trace the waterlines on rocks, can date buried shorelines and drowned forests. Myth can trace the waterlines in human memory, in our fear of losing home and order and meaning. Where they overlap is fascinating but faintly blurred, a zone of possibility rather than proof. Maybe there was no one great flood behind all the stories. Maybe there were many lesser floods stitched together by generations of storytellers into a single overwhelming wave that washed through human imagination. And in that stitched-together wave you can still hear the faint echo of real rivers breaking their banks, real seas rolling over fields, real people watching the water rise and wondering if the world was ending. For most of this story, we've stayed close to what the rocks, the ice, and the DNA. Imagine the world 12,000 years ago. Coastlines that don't exist anymore. Cities, if they existed, now under hundreds of feet of seawater. Entire landscapes drowned. Valleys that became oceans. Mountains that became islands. People who watched the waters rise generation after generation until everything they knew was gone. And here's the thing. They remembered. They told stories about it. Stories that spread across continents, jumped oceans, embedded themselves so deeply into human culture that we're still telling them today. Over 200 cultures around the world have flood myths. Not just any floods. The flood. A catastrophic deluge that nearly ended everything. The details change, the gods have different names, the boats look different, but the core story is always the same. Water rose, the world drowned. Only a few survived. Noah's Ark. That's the one most people know, but the Babylonians told the story of Utnapishtim thousands of years earlier. The ancient Greeks had Deucalion. The Hindus described Manu. The Aztecs spoke of Tata and Nena. Aboriginal Australians have flood stories. So do the indigenous peoples of North America, South America, and Polynesia. Cultures that never met each other separated by oceans and millennia, all describing the same nightmare. For a long time, people assumed these were just myths. You know, ancient explanations for natural disasters that early humans didn't understand. Tribal memories of local floods blown up into cosmic events. Humanity's way of making sense of a dangerous, unpredictable world. But what if they weren't making it up? What if something actually happened? Something so catastrophic, so widespread, that every culture that survived it passed down the memory? What if the Earth itself remembers? That's what this is about. Because modern geology has found something. Evidence written in ice cores, drilled from Antarctic glaciers, signatures in ocean sediments, fossilized shorelines hundreds of feet below current sea levels, underwater forests, drowned river valleys, ancient human settlements buried beneath the waves, and the timing's what makes it incredible. It all points to a period roughly 12,000 to 8,000 years ago, when the world was drowning for real. Sea levels didn't just rise, they exploded upward, in some cases jumping 10, 20, even 50 feet in a matter of decades. Coastlines retreated miles inland in a single human lifetime. Entire continental shelves, places where people lived, hunted, built communities, vanished underwater. We're talking about an event, or maybe a series of events, that would have been absolutely apocalyptic to anyone experiencing it. And people were experiencing it. Humans were everywhere by then, living along coasts, river valleys, anywhere near water. Which means when the water came, they saw it. They fled from it. And the ones who survived never forgot. This isn't pseudoscience or wild speculation. This is geology. This is what happens when Ice Age glaciers, thousands of feet thick, suddenly melt. The water has to go somewhere. It goes into the oceans, and when enough ice melts fast enough, the oceans rise catastrophically. Scientists call the most dramatic event meltwater pulse 1A. It happened around 14,600 years ago. Global sea levels rose between 50 to 80 feet in less than 500 years. Some estimates suggest it could have been even faster. That's not a myth. That's geological fact. So the question isn't whether a great flood happened. The question is when, where, and how bad was it? And maybe most importantly, what were people doing when the waters came? Were they just primitive hunter-gatherers scattered along doomed coastlines? Or was there something more? Something we lost when the seas swallowed the ancient world? Let's find out what the Earth remembers. Here's something that should make you pause and wonder. Almost every culture on Earth has a flood story, not just similar stories, nearly identical stories, a catastrophic deluge that destroys the world, a handful of survivors who rebuild civilization, waters that rise to cover mountains, and a very specific detail that shows up again and again, advance warning that nobody else believes. Let's start with the one you probably know best. The biblical story of Noah. God warns one righteous man that a flood is coming. Noah builds an ark, saves his family and breeding pairs of animals, survives 40 days and nights of rain, eventually lands on a mountain. The waters recede. Humanity gets a second chance. Simple story. Sunday school material. Except here's the thing. That story is borrowed. We know this because we found the original. In 1872, a British archaeologist named George Smith was translating ancient Mesopotamian tablets when he discovered something that shocked the Victorian world. He found a flood story that predated the Bible by at least 1,000 years, the Epic of Gilgamesh. And it wasn't just similar to the Noah story. It was basically the same story, detail for detail. A man named Utnapishtim is warned by the gods that a flood will destroy humanity. He builds a massive boat to very specific dimensions. He brings aboard his family and animals. The flood comes, lasting 6 days and 7 nights. When the waters recede, He sends out birds to find dry land. First a dove, which returns, then a swallow which returns. Finally a raven which doesn't come back, meaning it found somewhere to land. Sound familiar? The parallels aren't subtle, they're exact. Even the bird-sending sequence is identical. This suggests either the biblical writers knew the Gilgamesh story and adapted it, or both stories preserve an even older tradition, a memory so ancient that multiple cultures inherited fragments of it. But it doesn't stop there. Cross an ocean, go back thousands of years before European contact, and you find the same story among people who should have had no connection to Middle Eastern mythology. The Hopi people of what's now Arizona tell of a world destroyed by flood because humanity became corrupt. The survivors escaped by climbing into hollow reeds that floated on the rising waters. They emerged to repopulate a cleansed earth. The Ojibwe tribes around the Great Lakes describe a great flood sent as punishment, with a culture hero named Nanabojo who survives by floating on a log and eventually recreates land by having animals dive down to fetch mud from beneath the waters. Travel to India, and you'll find the story of Manu, warned by a fish that a great flood is coming. Manu builds a boat, the flood destroys all other life, and afterward he becomes the father of the new human race. The parallels to Noah are impossible to miss, but this story appears in Hindu texts that developed independently of Middle Eastern traditions. In China, the Great Flood is central to ancient mythology. The Emperor Gun tries to stop the waters and fails. His son Yu succeeds by dredging channels and controlling the waters, eventually founding the Xia dynasty. Chinese geological surveys have actually found evidence of a massive flood around 1920 BCE that fits the timeline of this myth remarkably well, but that's a story for later. Greek mythology has Deucalion and Pyrrha, sole survivors of a flood sent by Zeus to destroy corrupt humanity. They land on Mount Parnassus, receive divine instructions, and repopulate the world. Different gods, same story structure. Even in Australia, isolated from other continents for over 40,000 years, Aboriginal peoples have flood stories. The Bundjalung nation speaks of a time when the ocean rose and swallowed the coastal plains, forcing people to flee to higher ground. The Gunditj Mara people describe a great flood that covered the land, with only a few survivors escaping to mountaintops. And if you're watching this right now, wherever you are in the world, I'd love to know. Drop a comment telling me where you're watching from and what time it is. Are you falling asleep in California? Waking up in London? Somewhere I've never heard of? There's something beautiful about people scattered across the planet all wondering about the same ancient questions. So what explains this pattern? 3 possibilities, and honestly all of them are fascinating. First option, pure coincidence. Humans live near water, floods happen, scary floods become stories. Different cultures independently invented similar myths because floods are universally terrifying. This is the safe, rational explanation, but it doesn't really account for the specific shared details, the birds, the mountains, the handful of survivors. Second option, cultural diffusion. Maybe there was one original flood story that spread across the ancient world through trade routes, migration, and cultural contact. Stories traveling with merchants and refugees, mutating and adapting to fit new cultures, but preserving the basic structure. This works for geographically connected cultures, but it struggles to explain why isolated peoples in Australia and the Americas have such similar traditions. Third option, and this is where things get really interesting, collective memory. What if all these stories preserve genuine historical memory of real catastrophic floods? Not one single global deluge, perhaps, but multiple regional catastrophes so devastating they became burned into cultural memory, passed down through thousands of generations of oral tradition, until they achieved mythological status. Because here's the uncomfortable question that keeps researchers up at night. What if the myths are trying to tell us something true? What if our ancestors survived something so terrible that the memory of it literally couldn't die? 26,000 years ago, Earth was almost unrecognizable. If you could somehow travel back to the last glacial maximum, you'd find yourself on a planet that would seem utterly alien, terrifyingly beautiful, and completely inhospitable to modern sensibilities. This was a world locked in ice, a world where survival meant mastering environments that would kill you in hours if you made a single mistake. But it was also the world where humans proved they could adapt to anything, absolutely anything, if they were clever enough and determined enough. Let's start with the ice itself, because the sheer scale of it is almost impossible to grasp. Imagine an ice sheet covering all of Canada, all of it, stretching from the Atlantic to the Pacific. Now pile that ice 2 miles thick in some places. 2 miles of solid ice, heavy enough to literally push the Earth's crust down into the mantle beneath. That's the Laurentide ice sheet, and it was just one of several massive glaciers that had transformed the Northern Hemisphere into something resembling an alien world. Europe wasn't much better. The Fennoscandian ice sheet buried Scandinavia, Finland, and most of the British Isles under ice that reached thicknesses of over 10,000 feet in places. Picture this. The site where Stockholm stands today was beneath ice nearly 2 miles thick. London was on the edge of a frozen wasteland that stretched to the Arctic. Paris was tundra, cold enough that woolly mammoths grazed within sight of where the Eiffel Tower would eventually stand. Asia had its own ice problems. The Siberian ice sheet wasn't as massive as its North American and European cousins, but it covered vast territories with glaciers, tundra, and permafrost so deep it's still melting today, thousands of years after the Ice Age ended. Even places that weren't under ice were transformed. The Himalayas were even more heavily glaciated than they are now. Mountain glaciers extended thousands of feet lower than their modern positions. Valleys that today support villages and farms were filled with rivers of ice. But here's what really changed the world. All the water locked up in ice had to come from somewhere, and it came from the oceans. Sea levels during the last glacial maximum were approximately 400 feet lower than they are today. 400 feet. Think about what that means. The continental shelves, those relatively shallow underwater regions that surround every continent, were completely exposed. What's now seafloor was dry land, covered with forests, grasslands, rivers, and lakes. Entire landscapes that supported human populations, that had names and histories and cultures